so I'm going to test the transistors, and I've got one just underneath here so I can see what I'm doing. But if we look at the multimeter there, so that's just me touching the end. We have a look at what's happening with it. Clearly, that little transistor is toast. I suspect this one might actually work. I'm looking at that, and there you go, that's working. So that's, yeah, so that one's working. I could probably put that one back, and this is the that little transistor that's used to do the current limiting. As we can see, that one appears to be working. If we can just pin it down, yeah, so that one's good. So I've got two transistors that's good that I can put back in, and then we'll have to order obviously two other ones. I found that I did have a 220 stashed away somewhere, but I do need that 450. The next thing I'll do is I'll make sure that the circuitry is actually fine over here, and then before I go ahead and put those transistors back in again. Right, next step is let's see if we can ensure that the circuit's fine. Alright, so what I've got here is I've got the ECU hooked up, and I have the fuel pump currently turned on. I'm going to go for Q2, which is just up in here. What I can do is I'll maybe swap the, and I know that the middle pin is the supply from the micro, so I'm going to just check the middle pin. We can put to ground. You see there it's at 5 volts. So if I just hold this like this, and we go into our Mega Squirt software, I'll just turn the fuel pump off. You can see it goes down to 0 volts. Turn the fuel pump back on. We go down to 5 volts. So that tells me that the signal is arriving at that chip. That's good. What we will now do is make sure we get a ground, and what we'll do that, we look at the 40, that resistor there. Now if we turn the fuel pump back on again, yeah, it's on, and put the diagram up here so we know that this is it there. So this will be, that's a direct ground, that's grounded, and if I very carefully just do that, that's grounded there. So we know that that's all working. And if we have a look at the base of the next one, which is that one there, that's grounded. Well, it should be. That there is grounded, okay. And then this one here is 0 volts because it's the same as the resistor 16. If I just do that, excellent. So I'm actually very sure that all of this is working fine. Now if we look at the other one, which is on the idle circuit, so we'll need to go back and just set up a different one. Idle valve. The idle valve, we can do some funky things. Oh, probably won't, because this is not set up to, this is a different type of one, so maybe we'll use this one instead. Okay, if we use, so I'm just pulsing the idle circuit at the minute. I'm going to use the same strategy. And as you can see there, it's sitting at 1.2 volts. Just going to hold this like that, and we'll change it to on. Yes, we're happy with that. So we know that that's turning up on there. This should give me a ground. Yes, it does. Yep. Yep. And this will be off to the pin, so that's okay. We don't have that. Yes, a ground. Yep. That's perfect. Excellent. So I think actually the board's fine. It's just a case of now getting some new bits in there. The next step, I think what I'll try and do is just have a look at removing this blown chip here and seeing if we can replace it. Actually, no. We'll have a look and see what sort of mess is going on down here, because I'm pretty sure some of this is not quite the way it should be hooked up. So I'll spend a bit of time on decoding this. I'm not quite sure why all of this jumper wire is over here. It's up here somewhere, so who knows what's gone on there. So I just do need to spend a bit of time and try and work out what's been done here. So this is quite interesting. He's hooked up a wire up in pin 20 by the looks of it. That's a ground pin. Pin 2. 1, 2. And then that goes up to here. And then this is all shorted. And that goes off to that. Oh, I don't know. I think I'm just going to have to remove all of that. Remove this little bit of a circuit over here. I don't like that this is on the ignition. I think that that's the wrong place. It should be on an LED. And I think this is because of that mess there. That's going on in there. So maybe we just leave that bit alone. I'm not even sure. I think that's the FET drivers for the injectors that has been worked on before. Yes, I'm going to whip that wire out. That mess over there. I'm going to take that out as 2 because my understanding is that the ignition always needs to be on one of the LEDs anyways. So yeah, I think that's what we'll do. I'm not quite sure why he's hooked that up like that. It just makes no sense. And the thing here is too that I think this underneath here has probably got the potential for quite a bit of shorting going on, and that's probably why that gave up in the first place. Yeah, maybe we'll just rewire the whole bottom of this board and go from there. I think that'll be definitely the safest option. Right, so now that I've removed all of the crazy jumper wires, the interesting thing here is the way that this was set up. And when you look at the wiring diagram, what the guy had done is he had done a wire from there to there. And for the life of me, I can't quite understand why. I actually think that the wire needs to be, I think we need to make that connection and we need to make that connection, because I know that that vehicle there is using an HEI ignition system, so it's going to produce a square wave like so, and if we put that square wave in there, it'll go through the opto, and then if we do a jumper from there to there, that will work perfectly fine, because it'll then be opto isolated. So I think what I'll go ahead and do is put those jumpers in there so that we have at least that sorted out. So we'll go from pin 24, we'll have a square wave coming in through both these diodes, through that resistor, through the diode and the LED or infrared, whatever's inside there, down to there. And then we'll have a nice clean signal going into the ECU at 5 volts. So I'm going to do that first so we can get the that part of the circuit sorted. Once I've done that, I can then test that and get that to work. And then what I want to do is I want to set up the ignition system so that it will output the right information. So if we do that, if we look at the text select end of the board, which is this bit down here, it's a couple of those three over there. And if you flip it over, you'll see it's absolutely there. And remember, we want to go from text select to opto. So we're going to bridge those two. We're going to bridge that one, and then we need to bridge out those two, and then the output will be from opto to wherever it needs to go. We'll find where it is. Looks like that actually might already be bridged on the other side. You see, there it is. There's the bridge right there. So that's already bridged. So he is using the opto isolator to do the work, although he had some bizarre bridges going on here. So I'm going to just go ahead and resolve that. To have that all work properly. Where do I have? There we go. That's exactly what we need. Will that go in the hole? Yes, it does. Right. And then a little bit of bending. Now, at this point in time, I want to change this tip. It's way too big for what I was doing before. All my tips hide underneath. Okay. Thinking that that might actually be just a little bit. Okay. What we do want to do is we just want to do a bit of a clean up on that, on those two first. And there, I'll put on that bridge. I'll just turn the iron on so it'll take a little bit to just get up to the right temperature. Okay. Let's see. Is this warm enough? Yes. I'm just going to put a little bit of solder on there. With a bit of luck, we then use the wick. We'll probably be able to just pull that all out through the hole. Let's see. Maybe not quite, eh? Try and do a little bit from the bottom. And the thing with this is that it's right next to the map sensor, which makes it very interesting to get to. Try this one first and see how that goes. That one cleaned up nicely. Let's just try this one a bit more. This is where that stainless steel antenna wire comes in really handy, because we can quite easily just open the hole up like that. Right, so now look at that. That's open. Excellent. So now we've got our little bit of a wire together. It looks like it's a little bit of these. Let's see if we can just. Here we go. Okay, so I think we're in business with this now. You would have noticed that I'm going to leave a little bit sticking out on the top of it. Like a little bridge like that. And the reason why I do that is that when I need to do some testing, that makes it very handy to just clip the scope onto. Solder on there. There you go. Right underneath, see if we've got a nice good solder on there. Yeah, that one's. You can just flow it a little bit. I think we do. We've got a really good solder joint on there. Right. And now we can find the little tidy up underneath there. Right, so I think we're in business on that side now. That's certainly much better. It's not like that. Now the next bit we needed to do is we wanted to bridge these two. No, I don't know that they bridged. No, they're not. So we need to do a bit of a clean up on those. Definitely bring those two to ground. Okay. not sure if I can get to them from the top. I'm certainly going to give it a try. Okay, this one seems to be a bit of a challenge, isn't it? Heat, a bit of poking. There we go. Okay, so all going well. This will be. Come on, focus. Right, we're going to do another little bridge like we did before. And this bridge is just a straight to ground bridge, so it's nothing special. Just completes that circuit. I'm going to install it from the top. Maybe a little bit closer. Okay. Come on, you can go on. It's got something in the way of making it go through. A little bit of heat did the trick there. Hold on that, and that should make the tech input work beautifully. Okay. Okay, so the other thing I think I'm going to do while I'm in here is on the prototype board here, he has built a kind of circuit, and I think I need to just have a look at that. I suspect. Okay, so it looks like that's the ground. Just scanning the whole lot. Right, so we've got that now out now. Now it looks a bit yuck and ugly, so let's give it a bit of a clean up. Right, let's see. Right, so this is a transistor leak. We're happy with that one. And I think this is a transistor leak. That one's good. And this is a transistor leak. Okay, right. And we can confirm that by testing it. Okay, this. This is our base. Yep, that's good. That's good. Exactly right. Okay, so there's a transistor right there. So where is the emitter? The emitter should be connected to ground, and that is pin 1. Pin 1 is this pin on this end. So that pin there should be straight to ground. Now, if memory serves me right, as you can see that there is a ground. So all we need to do is just do a little bit of a bridge on there. That's what he had before. Right, so what we're going to do is we're just going to put a wire in there and then lay it across. And for that, we do need a little wire, which I've got one right here. Okay, let's just use this one. To get that to go in, I'm simply just going to warm this up here a little bit. And while it's warm, try and insert this little bit of wire like that. But now we've got that in there, we'll now solder it so it stays there. Alright, that's good. Do a little bit of a bend on it. To have that work right nicely, so I'm just going to trim the wire off there. You can come away. Right. Okay, right. A little bit of solder on that, and that will give us a ground path right there. Okay, right, so the LED is now connected to ground. Okay. Now this 10K resistor should be connected there and there, but this also becomes the output, and that should be connected to 5. And we can see here 5 volts right there. So I'll just put a bridge from there to there underneath, and then I'll do a bridge from there to there, but also an output pin right there. So where are we? From there to there. As you can see, there's a little bit of stuff left in that there, but that's alright. We'll sort that out in a hurry. And then we're just going to Bend over there. Snipping over there. Right. Welding. Excellent. Right, and then this now becomes a tricky bit. Those two need to be connected, but also give us an output. And at this point, we've got two choices. We can either put another bridge wire in. I'm going to simply put it through that hole there. And solder that, because that gives me a pin to work with on the top. Maybe not like that, eh? Okay. Since we've got that sorted, we can now cut a bit off there. Then it leaves us with those two, which is the drive for input for the transistor. Alright, so as you can see there, that'll probably just do the trick. Actually, in fact, I don't think I need that. I'll just simply go and do this. It might actually just be alright to do that. Right, so that being said and done, that should all be making that circuit work. Most of all, we've now got a pin on top that is lined up for that. So I'll go ahead and do, let's turn this off here. We've got the 4 wires that we want to run from here over to there, and that's the idle stepper, the stepper motor control. And once that's done, then it's just a case of getting those 4 transistors that we've removed over there replaced, and this should be all working again. With the exception of the prototype circuit that's sitting in here that's currently ready but not hooked up. The 4 wires that I've just put on there now, they're all over there. We could use a bit of hot melt glue and just put that on there. Right, so that all being said and done, we'll take care of that problem. So, to right there. Okay, so let's see. We've got sitting down there. As you can see, these LEDs are going to town. Pump and idle won't, because they, well, lack of a better term, they don't exist since we haven't put the board, the components back again. What I did want to see was whether we're seeing any AC activity on those 4 idle pins. which is right there. Oh, okay, you see now, that's interesting. So right there, some shit sticking out. A little bit of cleaning. And I still wonder what that looks like underneath that microphone. Okay. Let's go back to this camera here. Let's see what we're seeing. This is as I suspected. But ugly in there, and there's a lot of. And of course, it's so close to the end, you can't actually get to it. Let's see if we can look from this angle. Here we go. Let's get some focus on here. Okay. That'll sort that one out. Like this one. And the focus has drifted off again. I really need to do something about this thing. That tidies that up. What about that one there? I'm happy with that. Okay. Okay. Let's see. So if I didn't know any better, I'd say that seems to be working. Besides, it's exactly the way it was. So just a little bit tidier. Okay, so that being sorted, we need to now look at that bit there. And for that, we need to plug in this, and we now need to know what is our strategy for making this work. Let's share the screen here. Remember how I said before that when I did that bridge thing? Well, this is what makes it so easy. And what we want to do, let's do 20. Oh, that's 20 seconds, and I'm nuts. Right, so that there is the input on the crank. In this case, it's just get that nicely out of the way. But what we want to do now is we want to know, I've got channel 4, we'll just use channel 4, right? Is what is the output in this. Now that I've found the connector that I was looking for, what I'm interested to know is whether injector 14 is set up as the spark output. And it does look like it is. Now you'd say that that's backwards. Well, it isn't backwards because the LED has been driven that way. So if we look at this output here, that'll be the perfect output to use. Right there. So we can do that, or we can use that and invert the signal. My preference typically is to grab this one here. Just to grab it off the LED. And the reason why I do that is that I can, it's a little bit safer from that point of view. Although the voltage here doesn't quite seem to be zipping down to 0. So let us get the Tuner Studio running. We'll have a look at that, see if we can manipulate that ignition output. I don't know if you guys can see this. Yeah, we'll leave it there. Let's see if we see. It looks like he's got a cam input, but I don't know why, because that thing doesn't need a cam. See there, D16 is what he needs to have turned on. D16 is this LED, yeah. Alright, it wants power cycle. To make that happen, like you see there, that LED is now high. Okay, and what I'm interested here is I want to see if I can adjust bring this down to 1.7. I just want to see if it changes the pulse width on this. Yeah, it does. Excellent. So it is backwards on this. Which is essentially a problem. So what we're going to have to do is we're going to have to find the right output for this and feed that into the igniter module. I wonder if I can just invert that. We do that. There we go. That is much better. So if I now use that output there, although I think we're not coming quite down to 0 volts. I wonder what's on this one. Yes. All right. So I'm going to use that leg of the LED to do my spark ignition output. Going low. So we've just inverted it. It's backwards. Excellent. And now if we ramp the RPM right up, excellent. Now, an interesting thing that you will see here, and I don't know if you can, but this LED here changes. I need to figure out how that circuit's meant to work. Because memory serves, you need it to hold the pin high. Okay. But to make that module work, I need to run a wire from the bottom that LED resistor there, which is really the resistor that comes straight out. It comes straight out of the controller on there, and from there to the resistor I put in there for that little special circuit. So the choices I have is I can either run the circuit on top. Let's see if we can get the other camera up there for you guys. So where I can see it, that helps a lot. So the options I have is to simply run a wire from this point here to that point there. And I think that that's probably going to be the easiest solution, is to just simply straight over the top to put a little bit of a wire in there, because it means that it also gives us something to hook onto to test if we need to. So the question is, do we have a wire that's long enough to do that with? Look at that, that's just perfect. Right. So what I'm thinking is, if I go ahead and maybe give this a little bend here somewhere. Like so. Now what we can do is, if we lay this beautifully just down there, and of course now because it's what I want it to do. It's going to be difficult, isn't it? So my thinking is I want to solder it right here on the corner to hold it in place. That seems to be put it in place there. And we'll solder it down the bottom here. That's joined to that LED resistor there, and then I'm going to join it to this resistor over here. Right. Move it on. Excellent. Right, so that now will make that circuit work as intended, I think. And we can quickly check that by powering it up. You can see the LED there. We can maybe turn the light off. LED is on, and as we bring the waves up, it will go out. And that being the case, that the voltage will then change on the other pin. So that will being set and done. We just put this on the ground. On that pin there. Bring the rest down. Hold it on there. Bring the rest up. Gets to the point where it needs to switch over, and then it switches over, and now we've got 5 volts. So now we just need to figure out which pin that needs to go to, because we don't know which pin has been used here before. So the good news is I think we've got that mostly resolved now, apart from the upgrade. Why is that thing ring A? Right. Okay. I think it should be one of these. He had it hooked up to this one. Is that diagram to see what that tells us? Yeah, actually, I think I'll be happy with that, because it means that use that from the LED. Let's just confirm what we're thinking. Channel A. Let's see. Channel B. So as this now starts running, let's bring this down to some 5 milliseconds so we can see what we've got here. Oh, put a triple up on channel 1. 5 volts, yes. That's better. That's fine, let's put the vision. Okay. That's fine. Right, so what we're wanting to see is that this here is our ignition. Now what I'm interested to see is when I bring the waves up, the relationship stays the same. But we're not seeing timing changing at the minute, which is a bit of a problem. This could be because it's the ignition device is currently at 20 degrees. It's yeah. Trying to do is I'm trying to just move this over on the screen to the side there. This will bring this one across so we can see we've got this advance over here. And if we are bringing that up, the relationship does move because the ignition will fire on this here, and this is the crank. So as long as this moves up this way, you'll find that it will advance. See, there it is advancing. Let's see if we can mess with the table. That might be the easiest way of doing this. So use table. It's 10. Let's put in 25 in there. Burn. That's 25. Let's go 0. See that should be moving. It's not. Helps if you change the right bloody setting, doesn't it? Yeah, that's better. See how it moved? Go to 40. Excellent. If we didn't know any better, I'd say that that's working. So definitely if I use that pin there, that should do the trick for us, I think. So that pin there. Tiny bit of a clean up on that pin, I think. See how this LED is on? It means that that transistor is going to be turned on and the coil is going to get quite hot. So maybe what we need to do is then go back to the ignition settings over here and where was it? Power cycle, that's good. Turn it back on again. Right, so now we've got the LEDs turned off. Until we start running. Excellent. Now, the reason why we're having this, why we've had to do that, is because of the way that the circuit's wired. And if I go and grab the appropriate one, and I'll show you what I mean with that. So this is the pin that we currently hooked up on there. I'll share the screen with you so you can see what I'm talking about. I've got the yellow channels on the ignition LED. Let's see, maybe it's this side here. It's just going to be. So now we're getting the flashes from now getting the square pulse coming out. So the problem that we might experience here is this. Let's just the RPM up. So spark occurs here. So this here should be 3.5 milliseconds of dwell. Although I don't think so. I think this is backwards. We want to have that up instead of that. So the way to fix that would be to invert that signal again. Right, that actually looks better, although the LED is on or more on because it's when it's been turned. So no power turns on. We have spark over there, and then so we got less off, less on time. Now I'm suspecting, yeah, there's rev limit by the looks of it. So this poor thing can only rev to about 5,000 RPM with that, unless we drop the dwell. I'll bring that back to 3 milliseconds. It might actually give us a little bit more RPM. Where's the rev limit? I see the rev limit's at 5. Yeah, the thing probably can only rev to about 5 anyway, so okay. So that I'm happy with that. Now we just need to figure out where we're going to put our that goes to pin 3. Spare one. Spare one goes to pin 3. To me today, for whatever reason, nobody can see now. I'll bring the revs down. You see that corner LED turned on, the one down here. This voltage has gone down. If we bring it back up again, get the switchover point, and there you go. And that turned off. So I think that's going to work brilliantly to that module. Marvelous. So that solves most of the problems except for the chip on top here, which will a bit of a different challenge, and being that I am going to upgrade it, I'll probably leave that for another day. So the next step is I'll order those, and I'll make some notes on the pins that I've sorted out and changed, a little bit of a cleanup, and then we'll attack the upgrade.